Hi, trig class. In the last video, we were trying to simplify this expression. And the first two things you should do when you're thinking about simplifying the expression is, can you form a common denominator? Well, this one doesn't have a common denominator. It doesn't have a denominator. So there's no common denominator to form. Can you factor? Okay, they don't have a common factor. So I can't factor anything. So then you try the next thing is you try to use a trig identity. And tangent is sine over cosine. So that's one of the quotient identities. And we go from there. So we'd get cosine of theta plus the sine of theta times sine of theta over cosine of theta. Okay, so that would be cosine of theta plus sine squared theta, because sine times sine divided by cosine of theta. Okay, now we go back to our same strategies. Try to take out a common factor, but there is no common factor right now. But there's also not a common denominator. So we're going to try to form a common denominator. So we are going to multiply this one, cosine theta, by what the other one doesn't have, which is cosine theta. The second oldest trick in math is multiplying by the number 1. Because you don't change anything, but you're expressing the same thing differently. So multiplying by 1 doesn't change anything. Okay, and then I still have plus sine squared theta over cosine of theta. So now there's a common denominator of cosine of theta. So you get cosine squared theta plus sine squared theta. And that's all divided by cosine theta. And cosine squared theta plus sine squared theta. That's our most popular Pythagorean identity. Cosine squared theta plus sine squared theta is 1. So the top is a 1. So you get 1 over cosine theta. And we remember that 1 over cosine theta is secant theta. So I'll just put in secant theta. That's the answer to that one. All right, let's move on to the next one. The next one, you start out either usually taking out a common factor. There isn't a common factor. And if you can't take out a common factor, then you try to form a common denominator. Right now, there's a denominator, but there's no common denominator, so that would be the strategy that we try. So let's take that cotangent alpha and multiply it by what it doesn't have, then the other one does have, which is 1 plus cosine of alpha over 1 plus cosine of alpha, because if you multiply over 1, you don't change anything, but it expresses it differently in such a way that you hope you can simplify things. And you still have plus the sine of alpha over 1 plus the cosine of alpha. Okay, now you have a common denominator. It's 1 plus, oh, that's cotangent, not cosine. So I got to change this to cotangent. Okay. That doesn't change anything in terms of like strategy though. I would still go ahead and multiply by 1 plus cosine over 1 plus cosine, so it could make a common factor of 1 plus cosine, a common denominator of 1 plus cosine alpha, and go from there. Okay, so now you can put the numerators together you get cotangent alpha when you go this times this, and then cotangent alpha times cosine of alpha. You still have a sine of alpha, and then you have this common denominator of 1 plus cosine of alpha. Okay, so we formed a common denominator, and when you look at it, there's no common factor for every term. So then we're going to go on to step 2 because we look stuck, and we're going to try to use other trig identities. Okay, so for this one, I think I would take cotangent alpha and write it as cosine over sine. See how that changes things. Tangent is cosine over sine. So we're trying a different trig identity. So that cosine, so that plus sine. All right? And then that 1 plus cosine alpha is still on the bottom. Okay, now we're going to move from there. And when I do this, I'm going to lose my common denominator because these will both have a denominator of sine alpha, and this one doesn't have that denominator. So I'm going to make a common denominator there by multiplying it by sine of alpha over sine of alpha. So the strategy now is forming a common denominator, and I'm doing that strategy twice. Okay. So rewriting across the top row, we'll get cosine of alpha plus cosine squared alpha plus sine times sine, so that's sine squared alpha. That whole thing has a common denominator of sine of alpha because I made it have a common denominator. I built it that way. And you still have 1 plus cosine alpha in the bottom. So that whole thing is divided by 1 plus cosine of alpha. Okay, now I recognize the cosine squared plus sine squared as being my first Pythagorean identity. That is that cosine squared plus sine squared is 1. So I'm going to put a 1 in there now to simplify that part of it. So then I'll have one plus cosine of theta, or cosine alpha, I should say. That's divided by the sine of alpha. And I still have the 1 plus cosine alpha in the bottom. So that's divided by 1 plus cosine of alpha. Okay, so just to be clear, this guy is your numerator, 1 plus cosine alpha divided by sine of alpha, and your denominator is the 1 plus cosine of alpha. That's this guy. Okay, and I just keep working with that. I'm going to leave the blue top guy alone. There he is, the fraction in the top. And then this function at the bottom, 1 plus cosine alpha, I'm going to take the reciprocal of that and multiply it. Okay, then I see that it'll simplify some because the 1 plus cosine alphas will cancel out. And if you want to divide a fraction by just a single number, just take the reciprocal of that number and multiply. But I already had one of these guys in the numerator, so they'll cancel out and you just get 1 over sine of alpha. And 1 over sine of alpha is the same thing as cosecant alpha. So the answer to this one is cosecant alpha. Because we just used that 1 over sine of alpha is cosecant alpha. Okay, let's keep working here. Now, these were not identities. These were expressions. I didn't have a left and a right side. I just had an expression. But the strategy for working with identities or expressions are the same. Factor, if you can, form a denominator, common denominator if there isn't one, and then use trig identities. If you get really stuck, switch everything to sines and cosines. All right, so this one, now that we're doing a trig identity instead of just an expression, we're going to take this part of the advice, try to turn the complicated side into the simpler side. So when you look at this expression, the right side is a fraction plus a fraction. So this is the complicated side, and we would try to do algebra until we could make it look like the simpler side, which is 2 cosecant squared alpha. Okay, so we're just going to keep working on this guy until we hopefully make it look like that. Now the oldest trick in math is multiplying by 1, and we're going to do it here again. Because that's how you form a common denominator. So this one has 1 plus cosine of x in it, and this one doesn't, so I'm going to multiply by 1 plus cosine x over 1 plus cosine of x. Okay, multiplying by 1, so it won't change anything. The second one, which is 1 plus cosine of x, has the 1 plus cosine of x, but doesn't have the 1 minus cosine of x. So we're going to multiply by 1 in the form of 1 minus cosine of x over 1 minus cosine of x. Okay, now you got a common denominator. There's your common denominator, so put your numerators together, and we'll get 1 plus cosine of x plus another 1 minus the cosine of x, and the bottom is going to be 1 minus cosine of x times 1 plus cosine of x. So the cosines knock each other out, the ones in the numerator, and then add the two ones together, you get 2. If you were to multiply these out, you'd get 1 times 1, which is 1. The minus cosine of x would cancel out the positive 1 cosine of x, and you still have minus cosine times cosine, so that's cosine squared. Now I recognize this last one because that's the first Pythagorean identity. This is 1 minus cosine squared, and since cosine squared plus sine squared is 1, if I move cosine squared to the other side, I get sine squared. So here's what I'm saying. I'm saying that we already know that cosine squared plus sine squared is 1. So if you move this to the right side, you'll get sine squared is 1 minus cosine squared. So I can replace the 1 minus cosine squared with sine squared. Okay, so this becomes 2 over sine squared. That's the same as 2 times 1 over sine of x quantity squared, and 1 over sine of x is cosecant. So I'm switching that to cosecant. So this will be 2 times 1 over sine. So that's cosecant, and there's a square in it. So it's 2 over cosecant squared. That's this one, and I'll see you in the next video.